Part 2. What to know about encryption. While younger me wouldn't be able to tell you how XOR encryption works, the current me definitely can. But let's break down everything that I wanted to do phrase by phrase. Earlier, I said that my program will be able to convert one letter to another by first converting the letters from ASCII format to 8-bit binary, then performing XOR encryption using a user-created or a randomly generated key, then converting the letters back to ASCII. Let us start with ASCII and formatting, and to explain that, we also need to understand what a computer is. First up, computers are dumb, extremely dumb. No matter what you hear online or in the news about ChatGPT, there is no such thing as a computer that can understand anything. We can personify a computer's process to make it easier to comprehend and explain it, but it is just a tool. Much like a pencil, a computer is an extension of the user. If it could understand something, however, it will be two states. Those are knowing when a current is running through a circuit and knowing when a current is not running through a circuit. Decades of computer science and engineering have embedded the idea of a 0 and 1 into these states, so often we describe a computer as reading zeros and ones. A 0 just means that there's no electricity going through the wire, and a 1 means that there is electricity going through the wire. Thus, we can abstract our understanding by saying a computer can only read a 0 or a 1. In addition, we will replace the word wire with bit from now on. There are so many tiny wires within the motherboard that allows us to work with more data simultaneously. As a fun exercise, try finding out how we came to the name of a bit, and then type it in the comments. With this in mind, we can now understand where we are limited. We can't store anything meaningful in just one bit, and we can't expect the computer to automatically take a word and turn it into its own interpretation of bits. That's like asking someone to create their own number system. Sure, it could be better than the one we have now, but it causes more harm if people have to follow more than one way of describing numbers. That's why we will create a standard. A standard is arbitrary by its nature. There may not be a satisfying reason why it's so widespread, but the important aspects of it are that 1. A standard is easy enough to pick up, and 2. A standard is easy enough to use among other people. ASCII stands for the American Standard Code for Information Interchange. It was a standard created decades ago for use in telegraphs, and like many parts of a PC, was grandfathered into use for computing just so people wouldn't have to relearn a new way of doing things. At the time mentioned, and according to Wikipedia, ASCII only had 128 code points, with only 95 correlating to characters viewed on a screen. However, it was enough to represent the lowercase and uppercase letters of the English language, along with punctuation, symbols, and blank S characters like spaces. Just so everyone knows, the current information standard is Unicode. I cannot effectively describe how much of an upgrade it is, but ASCII was so decent that the first 128 characters of Unicode still correlate to the ASCII standard. I specifically use decent because once again, it didn't have to be perfect. It just had to be enough for the right people. As for the way I understand ASCII, imagine a string of 8 bits that have a specific combination of zeros and ones. An 8-bit combination correlates to a specific character, and that's it. 8 bits can create 2 to the power of 8 combinations. To say it another way, this method of using ASCII allows for 256 unique characters to be represented. There is some efficient organization, but that is essentially all you need to know. For example, the combination 01100001 correlates to lowercase a in the standard. If you want to explore more correlations, I will leave a link to ASCII translations in the description as well. Case in point, it is a pretty clean way to understand code, but it also does something else. Now, we don't have to concern ourselves with how we will manipulate an actual character. We can instead focus on manipulating the bits that the character correlates to, which leads us to XOR encryption. XOR encryption derives its name, at least to me, from the XOR gate. XOR is short for exclusive OR. and this gate seeks to find out if two bits are different. If they are indeed different, a true is returned. If they are the same, a false is returned. Decades of computer science have tied the value of true to 1 and the value of false to 0. So a true result will return a 1 and a false result will return a 0. When discussing XOR in the realm of encryption, one of these bits would be the 8-bit set you want to encrypt, and another one of these bits will be from a key. A key is a string of 1s and 0s you will use to scramble the first set bit by bit. When you apply an encryption technique bit by bit, this is called bitwise encryption. So in our bitwise XOR bitwise encryption, the 8-bit combination and the scene are lined up, and the XOR comparison is applied from the first bit to the last bit. The output would be a new 8-bit combination, which if we were to use the ASCII standard to convert, should show a new letter. That is the process I am trying to do. I want to be able to take a letter, decode it into an 8-bit combination, create a key of 1s and 0s, apply XOR bitwise encryption, and showcase the output combination. The last thing I'm going to do is call this group of 8 bits a byte. That way, we now have a word for grouping 8 bits of 1s and 0s together. And we can also understand that the byte can represent 256 unique characters using the ASCII standard. There's more stuff I can get into about how in actual encryption several dozen rounds are used to make the output look even more scrambled, and more details on the other gates I mentioned, but that will be outside the scope of this video. Core Dumped is a great YouTuber who explains the use of logic gates and bits well to create the very devices you are watching me on, so I'll leave a link to his channel in the description. In addition, I'll also leave there a site with all the conversions for binary to ASCII letters and the Wikipedia page for ASCII.